Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in a lecture number 4. Okay, in a lecture number 4 of surface areas and volumes. Okay, so I hope you will enjoy this lecture. This lecture is going to be very amazing because in this lecture we are going to be discuss a lot of problems. Okay, yes, so now, my dear friend, let's start without wasting the time. Yes, so today we are going to discuss surface area of a right circular cylinder. Of what? Yes, right circular cylinder. So what is right circular cylinder? A right circular cylinder is a cylinder that has a closed surface having two parallel bases on both the ends. Okay, you can see here is there are two bases. There are two parallel bases in the top and bottom. In the top and bottom. Okay, and there is a closed curved surface like this. Closed curved surface. Okay, so it is called a right circular cylinder. It is called a right circular cylinder because elements are perpendicular to its base. It means this circular base here is, you can see, means this is what, this is perpendicular to its base. So here we can say that here is this axis of symmetry, this center of line. Okay, this line which is passing from center, this is perpendicular. So we can say that this is called a right circular cylinder. All the points in a right circular cylinder lying on the closed circular surface is at a fixed distance from a straight line is known as the axis of symmetry. We are talking about this line. This is what, this is axis of symmetry. Okay, this is axis of symmetry, and the two circular bases of the right circular cylinder have the same radius. Have what? They have the same radius. They have same radius and are parallel to each other, and these two circles are what? Are parallel to each other. Okay, I hope you get this point, my dear friends. And the distance between two circular bases, this distance between two circular bases is what? Is h. Is h means height. This is what? This is the height of the cylinder. Okay, here we can write it as r is the radius of the circular base. Radius of the circular bases. Okay, and we know that these two circles have the same radius. Okay, and here is h is what? H is the height of the cylinder. Height of the cylinder. Okay, yes, now move on. So now here is, let's talk about the parts of right circular cylinder. So here if you observe this, there are three parts of right circular cylinder. Okay, what are these? So here first is top circular base. What is top circular base? Okay, and the second one is curved lateral face. What is? Yes, curved lateral face. And the third one is bottom circular base. Bottom circular base. Okay, I hope you get this point. So with the help of these three parts, this right circular cylinder is made. Now let's talk about the properties of right circular cylinder. So the properties are what? So the properties are, here you can see, the line joining the center of the circle is called the axis. It means Here we are talking about like this. Let's suppose we have a circle. Okay, here is this. Okay, the line joining the center. Let's suppose we have a line which is joining the center. Means joining the center of these two circular base. So we can say that this is what? This is axis. Axis. Okay. Now when we revolve a rectangle about one side as the axis of revolution, okay, the right cylinder is formed. It means, let's suppose we have a cylinder like this. Here you can see, let's suppose this is cylinder. Okay, this is what? Yeah, this is cylinder. Let's suppose this is axis of revolution. This is axis of revolution. Okay, now if we rotate this rectangle about axis of revolution, then a right circular cylinder is formed. Like this. Okay, got it, my dear friend? Like this. I hope you understand this thing. The section obtained on cutting a right circular cylinder is a plane which contains two elements and parallel to the axis of the cylinder is a rectangle. Okay, now if this action obtained by cutting a right circular cylinder by a plane. If we cut the right circular cylinder by a plane, like if we cut this cylinder by a plane, okay, if you cut this cylinder by a plane, so the section obtained, okay, which contain two elements and they are parallel to the axis of cylinder. Okay, this is what the rectangles. Okay, now the next one is, if a plane cuts the right cylinder horizontally parallel to the base, then it's a circle. Let's suppose we have a cylinder. Okay, if we cut it by horizontally, then this action obtained is what? Then this action is circle. And here if we cut the cylinder by a plane vertically, then we get this section which is rectangle in shape. Which is what? Yes, which is rectangle in shape. I hope my dear friend understand these things. Yes, so now let's talk about the curved surface area of a right circular cylinder. What is? Yes, curved surface area of the right circular cylinder. Now what is curved surface area? So the curved surface area of the right circular cylinder is as here is in this surface area of the cylinder excluding the top circle and bottom circle. It means we have to find the area of this circular part. It means we have to exclude the two base circle. Okay, now if we open this, this will convert it into the rectangle like this. Okay, and this is what? This is h. So the area is what? We know that the area of rectangle is what? Length into breadth, and here is length is 2 pi r and height is h, breadth is h, so we can say 2 pi r h. Okay, what is 2 pi r h? Okay, so we can write here is C as A, means curved surface area of a cylinder. Okay, so this is equals to 2 pi into r into h. It means this is what? This is equals to 2 pi r h. What is? Yes, so CSA of right circular cylinder is 2 pi r h. What is? Yes. Now let's talk about the TSA, means total surface area of right circular cylinder. So here is, so total surface area of right circular cylinder is curved surface area plus area of two circular base. Okay, so here we can write TSA of a right circular cylinder, is equals to, here is, this is CSA plus area of two circular bases, and we know that the area of circle is what, pi r square. So here this will become, so TSA is 2 pi RH plus 2 into, we have to find the area of two circular bases. Okay, so the area will be same of two circular bases, it means 2 into pi r square. And if we take 2 pi r as a common, so here we get h 2 pi r into h plus r. So this is what, this is the TSA of right circular cylinder. So what is CSA of right circular cylinder? This is 2 pi r h. And what is TSA of right circular cylinder? This is 2 pi r h plus r into h plus r, or we can say 2 pi r into r plus h. I hope you understand these things, my dear friends. So these are the surface areas of right circular cylinder. Now let's solve some problems based on these formulas. Okay, so here is question number 1 is, the curved surface area of a right circular cylinder of height 14 centimeter is 88 centimeter square. So we have CSA of right circular cylinder is 88 centimeter square, and we have height of the cylinder. Okay, then we have to find the diameter of the base of the cylinder. Okay, then we have to find the diameter of the base of the cylinder. So this is very easy, my dear friends, we can easily solve this question. Now here is height, means h of cylinder is what, height of cylinder is 14 centimeter, and let's suppose radius of cylinder is equals to r. We are taking this r centimeter. Okay, for finding the diameter we have to find the radius. Okay, and if we multiply 2 with radius we get the diameter. Okay, we know that diameter is equals to twice of radius. Okay, and we have CSA of cylinder is equals to 88 centimeter square, and we know that what is the formula, this is 2 pi RH, this is equals to 88. Okay, now here is the value of pi is 22 upon 7, so this will become 2 into 22 upon 7 into, we have to find r into, and the h is what, this is 14, this is equals to 88, this is equals to 88. So from this we can find the r. So r is equals to 88 into 7 divided by 2 into 22 into 40. Okay, so we can divide 88 by 2. Okay, how many times? This will goes to 44 times. And we can divide 44 by 22. How many times? 2 times. Okay, so 2 into 7 is what? 14, and in the denominator 14 is also left. So we can cancel 14 by 14. Here we get 1. Here we get 1. So now, so here radius is what? 1 centimeter. And we know that diameter is equals to 2 into radius. 2 into radius. So this is equals to 2 into 1, which is, yes, 2 centimeter. So we can say that the diameter of the base of the cylinder is 2 centimeter. Therefore, the diameter of the base of the cylinder of the cylinder is 2 centimeter. I hope my dear friend you understand these things. Yes, so the next question here is, it is required to make a closed cylindrical tank of height 1 meter and base diameter is 140 centimeter from a metal sheet. Okay, now how many square meters of the sheet are required for the same? We have to assume that pi is equals to 22 upon 7. Okay, so now here is we have to make a closed cylindrical tank. Okay, we have to make a closed cylindrical tank from a metal sheet of height 1 meter and base diameter 140 centimeter. 140 centimeter like this. Here you can see. Now we have to find the area. We have to find how many square meters of the sheet are required for the same. Yes, so now here is the cylindrical tank is what? It is closed. So we needed to find the total surface area of cylinder, which is in meter square. We have height h. This is what? Height h of cylindrical tank is equals to 1 meter. Okay, and the base radius is what? Base radius, we are assuming this is r. Base radius of cylindrical tank is equals to, we know that this is diameter upon 2. Diameter is what? 140 divided by 2. So this is equals to, yes, 70 centimeter. Now you can see that we have radius is what in centimeter unit and the unit of height is meter. So we have to change the unit. Okay, so here we are converting that 70 divided by 100, we get 0.7 meter. We are converting the unit of radius. Okay, got it my dear friend? Yes, so now here is, now area of sheet required, this is equals to total surface area, of tank, and we know that what is total surface area. So here is, this will become like area of sheet required is equals to, this will become 2 pi r plus h, 2 pi r plus h, and this is equals to 2 into 22 upon 7 into, here is r is 0.7 and 0.7 plus 1. Here we have h is what? 1. Okay, so this is 2 into 22 upon 7 into, if we remove the point we get 10 in the denominator, so this is 7 upon 10. Okay, into, this will become 1.7. So here you can see this 7 and this 7 will be cancelled. Will be what? Yes, will be cancelled. So after solving this, here we get 7.48 meter square. Okay, so area of sheet required, 7.48 meter square. I hope my dear friend you understand these things. So this is the answer of this question. This is what? Yeah, this is the answer of this question. Yes, so now my dear friend, so the next question here is, a metal pipe is 77 centimeter long. The inner diameter of a closed section is 4 centimeter. What? Yes, 4 centimeter. The outer diameter being 4.4 centimeter. Okay, you can see in the figure. Now assume pi is equals to 22 upon 7. So now find its inner curved surface area. First of all, we have to find inner curved surface area. Okay, we have a metal pipe like this. Okay, here is the height is what, 77 centimeter, 77 centimeter, and here you can see the inner diameter of the cross section is 4 centimeter. Okay, we are if we see that this is what, this is inner pipe. Okay, the diameter of the inner pipe is 4 centimeter and the diameter of the outer pipe is 4.4 centimeter. So first of all, we have to find the inner curved surface area. So for inner curved surface area, we have to take the diameter of inner pipe. Okay, means inner diameter. Okay, now for finding the inner curved surface area, we have to find the radius. So we can write it as inner radius. Okay, inner radius like r1, this is equals to inner diameter means d1 upon 2. This is equals to 4 upon 2. It means 2 centimeter. Okay, I hope you get this point. And we know that height of cylindrical pipe is equals to 77 centimeter. What is? Yeah, 77 centimeter. Let's suppose this is h. H is common in inner and outer as well. Okay, yeah, so CSA of inner surface of pipe, this is equals to 2 pi r1 h. Okay, I hope you get this point. So now here is, this will become 2 into 22 upon 7 into r1 is what, this is 2. Okay, into h is what, this is 77. After solving this, here we get, yes, 968 centimeter square. So this is the answer of the first part. Now let's see the second part. Now outer curved surface area. Now what is outer curved surface area? So for finding the outer curved surface area, we have to take this part. We have to take the diameter of 4.4 centimeter. We have to find this area. So now let's find that. So my dear friend, CSA of outer surface of pipe, this is equals to, here is 2 pi into radius of, yes, radius of what, outer cylindrical pipe. So this is, let's suppose this is r2 into h. Now r2 is what, here you can see r2 is equals to d2 by 2, means outer diameter divided by 2. So this is equals to 4.4 upon 2. This will be 2.2. This will be what, 2.2. Now put the value of in this formula. So CSA of outer surface of pipe is equals to 2 into 22 upon 7 into 2.2 into 77. 2.2 into 77. This will be cancelled by 11 times. By what? By 11 times. After solving this, here we get, you can see here 1064.8 centimeter square. It means 1064.8 centimeter square. So this is what, this is the CSA of outer surface of pipe. Got it? Yes. So the total surface area. Now we have to find the total surface area. So what is total surface area? Here you can see that curved surface area of inner cylinder plus curved surface area of outer cylinder plus 2 into area of base, means we have to find the area of the circular base. We have to add this also. Okay, yes. So here is, we have r1 which is inner radius, this is 2 centimeter. We have r2 which is outer radius, which is 2.2 centimeter, and we have h means height of cylinder, which is 77 centimeters. So TSA is what? TSA is equals to CSA of inner cylinder plus CSA of outer cylinder, okay, plus 2 into area of base, okay, because we have two circular base. Now my dear friend, here you can see, now we have to find the area of base. How we can find it? Here you can see, this is what? This is outer circular base and this is inner circular base. Then if we subtract this, if we subtract inner circular base from the outer circular base, here we get what? Area of base. So of circular area of circle with radius 2.2 centimeter minus area of circle with radius 2 centimeter, we get area of base. So here area of base is equals to area of circle with radius 2.2 centimeter. Because my dear friends, we are doing because here this is the space which is empty, okay, we no need to find the area of this part, so we have to subtract this part, okay, because this is hollow part, okay, that's why we are subtracting like this, okay. So minus area of circle with radius 2 centimeter. So this will become like pi r2 square minus pi r1 square. Pi r1 square. We can take pi as a common. We get r2 square minus r1 square. Okay, so this will become like 22 upon 7 into 2.2 square minus 2 square. So this is equals to 22 upon 7 into 4.84 minus 4. Okay, so area of base will become like 22 upon 7 into 0.84. After solving this, here we get 2.64 centimeter square. So this is what? This is the area of base. Now here in this formula, we have CSA of inner cylinder, we have CSA of outer cylinder, and we have area of base. Now put the values in this formula. Okay, so now TSA is equals to CSA of inner cylinder, which is 968, plus CSA of outer cylinder, which is 1064.8, plus 2 into area of base, which is 2.64. Here recently we find 2.64, and here you can see CSA of outer cylinder and CSA of inner surface 968. Got it? Yes. So after solving this, here we get 2032.8 plus, after multiplying this we get 5.28. So now the result is 2038 point, here is, this will become 08 centimeter square. 08 centimeter square. I hope my dear friend you understand these things. So this is what? This is TSA, total surface area. What is? Yes, total surface area. So this is the answer of this question. Okay my dear friend. Yes, so now let's move on. Yes, the diameter of a roller is 84 centimeter and its length is 120 centimeter. Okay, here you can see in this we have a roller in which the diameter is 84 centimeter and its length is, it means we can say this is what? This is the height of this roller, which is 120 centimeter. It takes 500 complete revolution to move. Okay, it takes 500 complete revolution to move once over to level a playground. Now find the area of the playground in meter square. Okay, then we have to find the area of playground in meter square, and we can take pi as 22/7. So for finding the area of playground, first of all we have to find the area of this roller, and then we have to multiply. Yes, we have to multiply with 500. Okay, got it? Yes, so now here is, now roller is in the form of cylinder. We know that this is in the form of what? Cylinder. So here radius is what? So radius is equals to, we know that, diameter divided by 2. Diameter divided by 2. And the diameter is what? This is 84 divided by 2. This is equals to 42 centimeter. What is? Yes, 42 centimeter. Now the area of roller, here you can see area of roller is equals to curved surface area of cylinder. What is? Yes, curved surface area of cylinder. Because if you roll this roller in the playground, okay, this covered just only curved surface area. Okay, so in this there is no needed of the base. So here we can write that area of roller is equals to CSA, okay, curved surface area of cylinder, which is equals to what? 2 pi RH. Okay, so here is 2 into 22/7 into R is what? 42 into H we have 120. Okay, after solving this, here we have 31,680 centimeter square. So this is what? This is the area of roller. Now we have to find the area of playground. So now here you can see, after one revolution, okay, here is, it means if we complete the one revolution, okay, then we can say that, yes, here you can see area of one revolution is equals to area of roller. Okay, it means after one revolution we can say that it is covered, which is equals to the area of one roller. So this is equals to area of roller. It means this is equals to 31,680 centimeter square. Got it? Now area of 500 revolution. Now the area after revolution of 500. Okay, so 500 revolution. So this will be what? This is equals to 500 into 31,680. So this will become like 1584,000 centimeter square. So this is what? This is equals to the area of playground. So this is what? Area of playground. So this is area of playground. Okay, now we have to convert it into the meter square. So for converting this, here 1584,000. For converting this, we have 2 centimeter. It means we have to divide by 100. Okay, and also 100, because we have to divide by 100 two times, because we have 2 centimeter. So this will become like meter square. So this 100 and this 100 will be cancelled like this. So we get 1584 meter square. 1584 what? Meter square. I hope, my dear friend, you understand these things. So this is what? This is the area of playground. Area of playground. I hope, my dear friend, you understand these things. So this is the answer of this question. Yes, so now let's move on. So the next question here is, a cylindrical pillar is 50 centimeter in diameter and 3.5 meter in height. Okay, now find the cost of painting the curved surface of the pillar at the rate of rupees 12.50 per meter square. Okay, we have to find the cost. We have to find the cost of painting. Okay, yes. Now here is, yes, so now here is, you can see pillar is in the form of cylinder. Okay, pillar is in the form of cylinder. Okay, and the curved surface area of pillar is what? We know that CSA of pillar is equals to 2 pi r h. Okay, and here is, you can see, now we have diameter which is 50 centimeter, which is 50 centimeter, and height is 3.5 meter. So here is h, we have 3.5 meter, and we have radius is equals to d by 2, which is equals to 50 divided by 2. This is 25 centimeter. Now you can see height is in meter and radius is in centimeter. Okay, so now here we are converting this centimeter into meter, so this will become 25. Okay, 25 divided by 100. Okay, so then we can write here is meter, so radius is equals to 0.25 meter. Now we can use h and r. Okay, so here you can see CSA is equals to 2 into 22 upon 7 into r is what? 0.25. Okay, into h we have, h is what? H is 3.5. Okay, so after solving this, here we get 5.5 meter square. What is? So this is what? CSA of pillar. I hope you get this point. Now, cost of, here you can see, cost of painting of 1 meter square area, which is equals to rupees 12.50. Okay, and the cost of painting, we have the cost of painting for 1 meter square area, then we can easily find the cost of painting for, yes, 5.5 meter square area, then we have to multiply this. Okay, so this will be 5.5 meter square area. This is equals to rupees, here you can see 5.5 into 12.50. Okay, so this will become rupees 68.75. How much? Yeah, 68.75. So we can say here is, therefore the cost of painting the curved surface area of the pillar is rupees 68.75. 68.75. Okay, I hope you get this point. Yes, so now here is, my dear friends, so the next question is, curved surface area of a right circular cylinder is 4.4 meter square. What is? Yes, 4.4 meter square. If the radius of the base of the cylinder is 0.7 meter, then find its height. Now we have CSA and we have, yes, we have radius of the base of the cylinder. Then we can easily find the height. And here we have to assume pi is equals to 22 upon 7. Okay, now let the height of the circular cylinder BH. Okay, we are assuming that. Now, and we know that radius R is equals to 0.7 meter. And we know that CSA of cylinder is equals to 2 pi RH. And this is 4.4 meter square. This is equals to 2 into 22 upon 7. And R is what? R we have 0.7. Okay, into H. Now if we remove this point, here we get 10 in the denominator, and we can cancel this 7 and this 7 very easily. So from this, H is equals to 4.4 into. Now shift these numbers to the LHS. Here we get this 10. If we shift to the LHS, this number goes to in the numerator. Okay, and 2 into 22 it goes in the denominator. So this is 2 into 22. Okay, yes. So now if we remove this point, here we get 10 in the denominator. This 10 and this 10 will be cancelled. Okay, this 22 divide 44 by 2 times, and this 2 will be cancelled. So here we get 1 meter. So the height of the cylinder is equals to 1 meter. So this is the answer of this question. Okay, this is the answer of this question. So now my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much for listening me, and take care and goodbye.